Hi, Sai. Hello, and welcome to this joint SPNHC Third Week 2024 conference. This is Contributor Oral Presentation Risk, Future Proofing, Data and Standards. I am your moderator, Javier Molina. Today is joining me also as co-moderator, Thierry Ang. So, this meeting was made possible in part by the generosity of our sponsors. We are grateful to them, and OK Congress today for the technical support. Okay. Well, I think we have had now quite a few sessions, so you know the drill. Basically, presenters are going to be running here the sessions for 10 minutes. We are going to have 3 minutes for Q&A, and then 2 minutes for changeover. For people that are online, please put all your questions in Zoom, and after the sessions, just go to Oxford Abstracts if you want to follow up the conversation. And for the presenters, if you haven't done yet so, please join Oxford Abstracts. All right, so without further ado, let me introduce our first speaker, and she's going to be presenting a recording online, and we will double check whether she's available for Q&A after this. So let's hand over to Erin Bailey. Thank you.
Hi, everyone. My name is Emily Conforto, and I'm an assistant registrar in the Office of the Registrar at the Smithsonian's National Museum of Natural History. This presentation today was created by the 4 assistant registrars from the Office of the Registrar at the museum: Erin Bilyeu, Kaylin Meyer, Jessica Nakano, and myself. The presentation will address mitigating risk in an ABS world, navigating third-party MTAs. The Nagoya Protocol, implemented in 2014, brought about change in how access and ownership rights are viewed in the natural history field. Through necessary changes to protect genetic access rights, scientific institutions have seen a rise in the use of material transfer agreements, or MTAs. These agreements are not standardized, but generally cover access and benefit sharing terms that govern rights and responsibilities regarding the physical custody and care of specimens versus the genetic access and ownership of the inherent intellectual property contained within biological specimens. These agreements often cover prior informed consent, mutually agreed terms, and responsibilities toward traditional knowledge. The purpose of these agreements is to ensure that scientific research continues while respecting the rights of origin countries to determine access to biological information contained within their borders. So what then is a third-party MTA? Well, a new trend has recently emerged with MTAs, including language about transferring custody of materials to third parties in the future. However, it can also require that the primary recipient negotiate a new MTA with the third-party recipient, rather than the third-party recipient negotiating directly with the country of origin. This is what we're calling a third-party MTA. This new third-party MTA often requires including non-negotiable terms from the original MTA. In many situations, the primary recipient must then ensure that the new third-party recipient adheres to the terms of the new and original MTA in perpetuity. All future recipients of any material originating from these MTAs are required to abide by these non-negotiable terms and to enter into an MTA with the previous institution. There are often also reporting and tracking requirements. Here's an example of language from an MTA that outlines the parameters for negotiating third-party MTAs for the specimens in the future. You can see that there is required language from the original MTA that must be included in the third-party MTA, as well as reporting and tracking requirements. Here's another example of language from an MTA, which outlines that the primary recipient will ensure that the third-party recipients adhere both to the third-party MTA terms and the terms of the original agreement with the origin country. There are many risks to using third-party MTAs. Many MTAs have burdensome reporting requirements, and there is no limit to the number of third-party MTAs that can be signed. Adding this additional layer of third-party MTAs with each MTA potentially resulting in secondary, tertiary, quaternary recipients of material, creates risk. Additionally, there are no systems in place to allow for the robust tracking that such MTAs would require. If the country of origin asks for publishing data on a specimen, the museum may be required to track down transfers many degrees of separation away and rely on coordinating collection data from numerous organizations and individuals across the world. Next, this has the potential to create scenarios where the primary recipient would be held responsible for ensuring that other museums and institutions uphold another country's laws or terms from an original MTA agreement which they themselves did not negotiate. There are serious consequences for breaking the terms of MTAs, so it's important to know what terms your institution can realistically agree to. Currently, the process for reviewing MTAs with third-party restrictions can be really burdensome. These are the steps NMNH has identified as required for all materials received that have third-party transfer restriction language. The volume of material received at NMNH every year makes this an unsustainable path for us. Now, I mentioned before that there is no limit to the number of third-party MTAs that can be signed. So imagine if the steps I just outlined were to follow to each receiving party, creating a waterfall-like effect. Depending on the wording of the original MTA, the current holder of the material may be required to report back to the previous holder, who would report back to the one before, all the way back to the original institution. The first recipient may also be responsible for enforcing adherence to the MTA for all of the subsequent institutions down the line. This creates risk for the institutions involved in this chain. At the Smithsonian's National Museum of Natural History, we typically only negotiate incoming MTAs, but we do not initiate MTAs. When materials owned by NMNH are distributed to other institutions, we do so by way of a restriction-free donation letter, noting any restrictions that were placed on our custody and that the new owner is responsible for negotiating those restrictions directly with the rights holder. You may recognize that this is exactly the way other types of intellectual property rights work. We propose that access to genetic information be considered in the same way. One may own an object without the rights to its origin or production, but all negotiation for use lies between the current owner and the rights holder. Interim holders' obligations are negated upon transfer to a new owner. We're in the process of developing a more consistent response to these complex agreements. Here's an example of how NMNH has recently dealt with a third-party MTA language. We agree to inform any third parties of the original MTA agreement by providing a copy of the original MTA agreement with the transfer paperwork, but we would not negotiate a third-party MTA, and we did not take on the liability of enforcing those terms to subsequent recipients. As my colleagues and I think about developing a more consistent response for receiving material with third-party MTA language, we've defined the three options for moving forward: loans, embargoed acquire, or accepting third-party restrictions. Option 1, only accept material for loan and express research purposes. In this option, NMNH would not accept material with third-party MTA restrictions as donations. We would only accept the material as a loan with strict tracking and return procedures so that we can still participate in scientific activities and research without having to sign a third-party MTA. This is the option that the Office of the Registrar suggests our museum adopts. Option 2, accept the donation, but embargo specimens to in-house use only. NMNH can accept the material and acquire it with restrictions. NMNH staff could use the material, but we would not transfer or loan it, and external parties would be prohibited from accessing the material. All MTAs would need to go through the official MTA review process. In this scenario, once the MTA was signed, we would need to label all MTA material physically and in our collections management system, EMU. Staff using the material would develop a system for reporting yearly on publications and other requirements listed in the MTA terms. Option 3, accept the donation and allow third-party transfers via third-party MTAs. NMNH can accept the material received under the MTAs with third-party clauses. We would allow third-party transfers and loans via third-party MTAs that we would sign with secondary recipients. All MTAs would go through the official MTA review process. In this scenario, we would need to flag all MTA material physically and in EMU. NMNH staff using the material would develop a system for reporting yearly on publications and other requirements listed in the terms. NMNH staff would also need to negotiate a third-party MTA with any secondary recipients. These third-party MTAs would need to go through the same official MTA review process as the original. NMNH staff are required to set up a tracking system for all recipients of the third-party MTAs and send annual reports on those recipients' use and research as directed by the MTA to the country of origin. Note that at this time, standard guidelines for reporting have not yet been implemented by most Nagoya countries. Our recommendation is to default to option 1, with caveats that mission-critical decisions can override the default with a clear and documented decision that suits the needs of all parties. As always, these decisions should lie within the authority structure of each institution and should not be taken lightly. In order to successfully implement any system for MTAs, we need community effort and cooperation, both from Nagoya signatory countries as well as those who have not signed. Sharing resources is an important part of being part of this scientific community, and we think community resources such as the ABS Clearinghouse could be used to further share template language and other resources that could create more consistency, cutting down on agreement negotiation times and increasing collaboration between countries. Finally, it's important to negotiate within your own organization. Figure out a consistent process which accounts for what your staff is able to realistically handle. It takes a lot of collaboration to be successful with MTA negotiations. We've reached the end of the presentation. If you have any questions, please email nmnh_registrar@si.edu. Thank you for taking the time to listen and enjoy the rest of the conference.
Thanks, Emily, and apologies because I originally introduced you as Erin. Can we have one quick question for Emily? Nothing here in the room? Anything online? All right. So if nothing else, let's just move to the next session then. So the next presentation is also online by Fritz Pichardo Marcano. So we're going to play a recording, and Fritz is online for questions after this.
Hello everyone. So today I'm going to talk to you about how biodiversity collections measure success, how these are aligned with their parents' organizations, and why this is important. So I want to begin recognizing that in recent years there has been a growing need in the biodiversity collections community of documenting the value that collections provide. This is evident in the growing interest in strategic planning for herbaria. As an example, we have the growing participation in courses for strategic planning herbaria led by Austin Maas and David Jennings. Also, there's a need to track progress and evaluate performance, and a way to better document evidence of the value that these collections provide. In recent years, we have witnessed concerning events like the closure of emblematic and large collections, which attracted attention not only within the scientific community, but also the broader media. We have also seen controversial relocation of collections, and also instances where smaller collections are being merged with larger ones for different reasons. So these events highlight the urgent need to address how we measure and communicate the value of our collections. These issues may potentially stem from a disconnect between collections and their parent organizations in terms of vision, mission, and goals, the lack of widely agreed upon methods for documenting the value of collections, or also a misalignment of expectations between administrators and collection professionals. It is worth noting that parallel studies in adjacent fields have explored similar issues. For instance, the Botanical Gardens Conservation International, in their technical report of 2017, they examined how botanical gardens measure performance and success, and they found that while botanical gardens share similar baseline roles, they often prioritize different areas such as conservation, horticulture, education, or research. Importantly, they noted that not all botanical gardens produce strategic plans, possibly due to their size or integration with larger parent organizations. And when the strategic plans were available, many of these did not provide metrics of success. So, keeping this in context, this project aims to describe the major activities prioritized by collections and parent organizations, identify how collections and parent organizations measure success in those activities, and evaluate the alignment of success metrics and activities between collections and parent organizations. So let's start talking about how we proceeded with the project. So we first began by collecting data from United States herbaria from Index Herbariorum, which listed 727 herbaria. It's important to note that this number represents registered herbaria, not necessarily all current active ones. For instance, the 2021 Index Herbariorum report indicated 642 active herbaria, while in 2019 it was reported 686 active herbaria at that point. So you can see this number fluctuates over time. Our analysis revealed that the majority of herbaria, approximately 65%, are affiliated with universities and colleges, and this aligns with previous findings by Barkworth and Murrell in 2012 and Tears 2020, highlighting the intrinsic link between herbaria growth and the growth of academic institutions in the United States. So museums and botanical gardens account for smaller percentages at 6% and 3% respectively, with the remainder distributed among various organizations such as parks, field stations, and other governmental entities. We then proceeded to search for publicly available online documents from these herbaria and their parent organizations that could provide insights on how they measure success. So our initial focus was on annual reports and strategic plans, but due to the limited availability of this type of documents for herbaria, we expanded our scope to include web pages. We found relevant documents for 173 of those herbaria, around 23% of those. And from those herbaria that actually had documents, the great majority of them had only web pages information available. We then proceeded to annotate these documents, taking the approach of systematically grouping activities that describe or potentially describe success metrics by topic, subtopic, and also extracting the success metrics themselves from these descriptions. So to achieve this, we use a collaborative annotation tool called Inception, which facilitates dealing with complex data annotation tasks. I'd like to share some preliminary results comparing the distribution of topics between herbaria and their parent organizations. Focusing first on universities and colleges, it is important to note that the percentage shown in the chart represents the percentage of institutions mentioning each topic in any of the documents that were annotated from this. So not necessarily correspond to the importance in the sense of the amount of dedicated space for these topics in the documents. For herbaria in academic institutions, the most frequent topics are collection scope, education, and digitization. And we also see an alignment with education, which is also the highest ranking topic for academic institutions. Despite the alignment in education, there are notable discrepancies in the frequency of mentions for collection scope and digitization for universities and colleges. Looking at it from the perspective from the other perspective, topics that were important for colleges and universities, such as funding and diversity inclusion, were not widely mentioned in the herbaria documents, we see low percentages like 21% for funding, 80% for diversity and inclusion. And this mismatch highlights the potential disconnect between priorities of herbaria and their parent organizations. Okay, so now let's take a look at herbaria where parent organizations are museums and compare this to museum institutions themselves. I want to point out that that we are working with some pretty small numbers here, and we need to be careful on how we interpret this data. We can see that in the herbaria side, collection scope, digitization, and education are the most frequent topics still. Yet for example, education percentage drop a bit compared to what we saw with universities, and now accessibility is also high on the list. On the museum side, we see that education and accessibility are still on the top 4, but the digitization and collection scope are low on the list. Now let's take a look at what is important in terms of frequency of topics for museums. So we see here that the highest topic is community engagement with 78%. Then we have accessibility, education, funding, and research at similar levels. Looking back at the herbaria side, we can see some disconnection in the activities related to community engagement, which are not so frequently mentioned in comparison to museums, and so is funding that is low on the list. Topics like education and accessibility are like comparably similar. Now looking to herbaria that belongs to botanical gardens and arboretum institutions, we can see collection scope topics are the highest in frequency, and we'll also see high up the digitization, accessibility, but something interesting is that that we also have preservation high up in the top with a little bit more than 70% of herbaria including topics related to this preservation. So contrasted to what we see for botanical gardens and arboretum, we see again discrepancies mainly on collection scope, preservation, and digitization. So when looking at the botanical gardens and arboretum side, we see the community engagement at the top, which is similar to what we see in museums, then funding, accessibility, and diversity and inclusion as frequent topics too. However, we see big discrepancy of these topics for herbaria. So the main takeaways of what we've been able to process so far in these preliminary results, we want to note that most herbaria have parent institutions that are academic. Fewer herbaria than expected publicly share documents such as annual reports and strategic plans and have information about them on the web. And this lack of publicly available information may hinder efforts to understand and communicate the value of collections. Herbaria from academic institutions tend to align with the parent institution on the frequency of education topics, yet many herbaria show a disconnect with their parent organizations based on the topic of frequency of funding, community engagement, and diversity and inclusion. So as part of our next step, we want to evaluate the relationship between collection size and the prioritization of different activities and success metrics. And in general, so far, our findings highlight the need to address how we measure and communicate the value of our collections, developing baseline for success metrics in the international community collections community, which would help ensuring a long-term sustainability and support for biodiversity collections. And with that said, I want to say thank you so much. I also want to thank the National Science Foundation, which funds grants by grants, bio projects, which allow projects like this one. And we are really thankful for this opportunity. Well, thank you so much. Any questions?
Thanks, Fritz. Fritz is online. Do we have any question here in the room? Yep, please.
Thank you very much. So I wonder if I missed it, but do you have examples of the type of information you find in the documents that define the metrics? I would be interested in knowing. Yeah, thank you.
Do we have Fritz on the main screen? All right. The team is trying here to bring Fritz on the main screen.
Otherwise, I can also ask in the chat. It's fine. I just, yeah.
Yeah, no, that's right. We can see Fritz there. Are you muted, Fritz? No. Is that Fritz on? No. Can you enable your camera, Fritz, and probably your mic? Yes. All right. Well, looks like we are not getting much progress with Fritz. Well, thanks for that, yes. So if you can address any questions on the Oxford Abstracts chat, that would be great. So if nothing else, I'm going to ask you to hold for another 5 minutes. We start at 30 past the hour, so we don't go too far ahead because there are people that have organized and want to attend other sessions. So I give you now 4 minutes.
Yes, you didn't anyone tell you? Yes, exactly. Interpreting. Yes, inquisitive dancers kind of comment, it's your choice. Yes.
You guys.
We need a comic.
Yeah, sorry, I missed my opportunity to sing for you guys. All right, let's get back on track. So, moving on to the next session, we have this, also our last participant online for this session, Dimitri Mosarin. So we are going to play the recording, and Dimitri is also online, just waiting for questions after this. Over to you guys.
Hello, my name is Dima Mazerin, and what I want to talk about today is a SQLite database. How can we use SQLite as a frictionless solution to exchange biodiversity data? So let's start. in biodiversity, we don't need to change data between researchers, between organizations, between different aggregators, and so on. And when we do it, we can do it by Word documents, we can do it by Excel spreadsheets, but it is not very convenient way. And because of that, TDWG appeared. And TDWG developed quite a few standards, and these standards help us to exchange data much easier between each other because both sides agree how the standard looks like. However, standard itself is not enough. We also need another standard for moving data from one place to another, particular files. And one example of this is Darwin Core Archive. In exchanging of the data, what people normally use are either XML or CSV or JSON. All of them are textual formats, and they can move data from one place to another quite successfully. However, all of them have a problem. When you get data in these formats, this data must be parsed. Parsing is very often not trivial. Large XML and JSON files are slow to parse, and they take so much memory that they can crash your computer. CSV, from other side, has many varieties and often has problems with encoding. It is very hard and slow to query data in such files, so data must be moved to a database. And we get a crazy idea. Why don't we use database itself to exchange data between different people? And this seems to be not very doable because databases are complex, databases change a lot from version to version. But there is SQLite. And what is SQLite? It is very simple compared to other database, but it is also very performant. If you open computer or you open phone today, you already used it. It is installed practically on every laptop, on every desktop, and so on. Database itself is just one file, so it is very easy to move around. This format of SQLite stabilized a long time ago, and developers promise that format of the database will not change until 2050. So if you have the database in the medium and near future, it will always be open with no problem. Database can be put either in textual or in binary format, both are fine. Database can handle terabytes of data. It enforces UTF-8 encoding, so no problems with encoding. And practically every popular language supports SQLite. It is so good for archival that even US Library of Congress decided to accept it as a data archival format together with XML and with JSON. And we propose to create SQLite archive. So it would have its own schema. This schema would have data and metadata together. There is no need to create several files. And schema can be stored on GitHub, and we can use Git tags to version them. Using semantic versioning, different schemas can interoperate with each other, different versions of the same schema. For example, if all of them are version 1, they should understand each other. Importer and exporters can be written in any language and still work together very well. So we at Species File Group decided to try this idea and create SFG Borg. We think about it as a future universal converter between different data that we use. We have a Global Names project, we have Catalog of Life project, we have TaxonWorks project. It would be great to exchange data between them, between these three projects, and also take data out of other projects and put data into other projects as well. So, for example, we can have an importer for Darwin Core archive that moves data from Darwin Core to SQLite archive. And then we have another exporter that takes SQLite archive and moves data to ColdDP, for example. Any combination of importer and exporter is possible, so this is very convenient. Importer and exporter are completely independent from each other. This is why we can combine them in any way. Importer and exporter can be written in different languages. It will not prevent them to work together. We also think about using semantic versioning. So what is semantic versioning? In a nutshell, it has a major version, medium version, and a sort of bug version. And the convention is that if major version is the same, it doesn't matter everything else, different versions will be backward compatible between each other. And this can be very useful to connect importers and exporters written for schemas of different versions of this archive. SQLite can be used as a result as exchange media. In this example that we are going to show, we download Darwin Core archive of Catalog of Life, we convert it to SQLite archive, and then we upload data from this SQLite archive to Global Names Verifier database. So when we do import, Catalog of Life is a pretty big data set, 5 million rows in the core Darwin Core. However, it takes not that long time, just 9 minutes on a laptop to move it to SQLite. And when we transfer it, because it's already prepared in the database, it takes even less time, just 4.5 minutes to transfer whole Catalog of Life from SQLite archive to a database. So altogether, it's only 15 minutes. SQLite archive is a standard database, which is also can be used as a backend for applications. SQLite archive would have known schema, so anybody can develop application using that schema. And we might end up with a growing ecosystem of web and desktop applications that use SQLite archives directly. If you are interested to see our experiment, you can find our schema, our importer, and our exporter using these links. And this is all about this talk. So this is our group, species file group, and thank you for your attention.
Okay, so Dimitri is online. Do we have questions for Dimitri? Yep, please, Rod.
Hi, Dima. It's Rod. I was curious that I presume you're aware of the dataset project that Simon Willison has got running. This is a project which basically you can give it any SQLite file and it'll package a website for you that you can query. So it's not necessarily going to be as flash as a custom built one, but basically you just have a generic database. He can give you a way to query it, package it, send it to people. Have you come across this package and have you any experience in using it?
No, I didn't see it. It's very, very interesting.
Yeah, it might be worth having a look.
Yeah, thank you.
Sorry, we're just having a little. It's data set as an SETTE, like cassette, but data set. And it's a very cool thing that Simon Willison, he's got blogs and everything. I recommend people have a look at it so you can really quickly package a SQLite file. Cheers.
Yeah.
Would you mind sharing that, Rod, on the Oxford Abstract chat? Yes, there is a chat. We have a question. All right. We have a question online.
Yes. So questions from Chijenko. Do you develop any data validation within SQLite? How does it work?
It is pretty it's just a database. So it does have it is very simple database compared to other ones. It has much less types than and types are actually optional. But of course, if you want to have more structure, it makes sense in the schema to have types introduced. So I would say that for validation, the same as, like, for example, for Darwin core file, which is just, a bunch of text files. Validator is something that understands internal structure of a Darwin core file, and it validates it accordingly. So it is the same thing. You have just a database with a known structure, and the validator goes through it, finds if everything is right.
Any other questions here in the room or online? Okay. I might jump in with one, and probably it's more of a comment, Dimitri. Just attending yesterday the workshop for Latimer Core. I thought it was an interesting exercise to work on a importer and exporter, precisely to try that one. The workshop material is prepared on Airtable, but I think SQLite, it'll be also an interesting scenario to try it.
Yeah, interesting.
All right, unless there are no more questions, let's move. I'm going to thank you, Dimitri. So let's continue moving on. So we have finished with all the sessions online. So moving here to the room, we have Jim Zhang as the next presenter. Yes. Over to you.
Okay. Good morning, everyone. My name is Jujun Zhang, and I'm a developer in TypeIF, which is one of the GBIF nodes from Taiwan. And in today's presentation, I would like to talk about supporting biodiversity dataset preparation and introduction to the TypeIF Open Data Toolkit. Some of you may wonder why and what is TypeIF Open Data Toolkit. Sorry, so let's jump into the point. I think all of us in this room would agree with that open data is challenging for the beginners because of these reasons, and they always look like this. Thank you, that's what I need. However, for Taiwan community, what's worse, all the documentation is in English. So that makes us think about what if we can have an all-in-one application which is easy for Mandarin-speaking users and could also improve data quality. So here comes TypeIF ODT. And in this field, we have multiple amazing standard and application for process biodiversity open data, like this of them. So we integrate the advantages of this standard and application into TypeIF ODT. Then here comes the next question. What can TypeIF ODT do for us? Here's the overview diagram of TypeIF ODT. Briefly, the user can start from data project and build their own data template. Then they can walk through the data editing, data validation, and data cleaning. Finally, they can export the entire data set. So in the following slide, let's go through each step and explore the features of TypeIF ODT. In the very first step, data project page, the users can create a new project or open the old one and jump to the data editing page. Then in the following demonstration, I will start with create a new project and go to the data template page. In this page, the users can select the core and extension by using the dropdown. For example, I choose sampling event as the core, and the terms related to sampling event core will be listed on the page. When the user hovers their mouse on the terms, the definition of that specific term will be shown on the right-hand side. In addition to the Darwin core terms, the users are allowed to custom their own terms. After selecting all the required terms, they can save these terms as a custom template so they can be reused in the next time. And one of the highlights in this page is that we have already classified these terms into required terms, recommended terms, and optional terms. So the users do not worry about they will miss any required terms when publishing data to IPT. What's more, we also have the theme drop-down. For example, I choose the ecological survey as the theme, and the sampling event core and Darwin core occurrence extension will be set as default. Also, the terms in the theme and extension will be listed on the page. Then, let's move on to the data editing page. In this page, the users can switch the tables between the core and extension by clicking on the tabs. And as for the operation of the tables, it's just like Excel. All the changes on the table will be saved automatically. What's more, when the user hovers the mouse on the header, the definition of that header will be shown on the left-hand side as the reminder. And we also designed some useful functions for the table. We have faucet by column, import table, and export table. And another function is add rows. The user can just input a number into the input box, and the number of rows will be added below tables. And let's move on to the next step. It's data validation page. In this page, a user could also click on the tabs to display the information between the core and the extension. On the lower part of left-hand side, it shows the overview of each terms. And on the right-hand side, it shows the error message of validation result. For example, in the first accordion, it tells the user that there are duplications in occurrence ID. And there are more details when the user expands the accordion. Also, the user can export the entire validation result as CSV file. Then we can move on to the data cleaning page. And personally, this is my favorite page because I spent a lot of time on coding it. So the amazing part is that the user can check the error messages and clean the data on the same page. They do not have to switch between the application or different pages. And in the error message section, it shows the identical information as it in the data validation result. And the rows with arrows will be highlighted in the red, so the user can easily to find which where is the arrow. What's more, we designed the additional useful function. We have content faucet, which is useful for batch modification. And second, we have text filter. It would help the users to find out the specific rows easily when they have multiple rows in the tables. And after cleaning the data, after cleaning up all the data in the table, the user can always validate the data again. And finally, we clean up all the data in the table. And at this time, the user can export the entire data set as the CSV zip file, which can be uploaded to IPT directly. And it's the introduction of TypeIF ODT. And at the end, I would like to thank for the financial support from this organization and all of your attention. Thank you.
Thanks. Do we have any questions here in the room? Oh, plenty. Come on. Speaker number, please.
My name is Sasit Rajbandari. I'm from Cairo, Australia. So I have two questions. So first one is, this tool looks very impressive to me. So I would like to know, like, how big datasets can it handle? So when we work with the eDNA datasets, we have millions of records. So do you think Is there any restriction with the size of the?
I think the tables can handle up to 1 million rows at once.
Thanks. Looks good. My other question is like, where do you store these templates? So is it project-based and you store it locally?
Yeah, I store the template locally in the SQLite database.
Okay, that's good. One more use of the SQLite
Yes.
database. Is the source code available so that we can reuse your toolkits, or how is it at the moment?
We will release the application on GitHub, but source code, maybe we will have more discussion to discuss whether to open or not.
Thank you so much.
Thank you.
Thanks.
Congratulations for both a practical and educational tool. I love the user interface. My first question is, do you plan to translate it in other languages? The second question is, the data validators, did you implement them yourself, or are there a set of open source data validators to run against Darwin Core columns?
Okay.
Thank you.
So currently, like I just mentioned, it was designed for the Mandarin-speaking users. So we don't have plan to translate into different language. But if we have a chance to contact with the translator, maybe it is a good opportunity to do so. And the second question is, sorry, I forgot about it.
No, it's my bad. I should have asked separately. But the data validators, I assume that validating Darwin Core data is a very common problem. So are there a set of reference open source validators that you could use, or did you implement the validation yourself?
Most of the validation functions are written by myself, but a little part of them are implemented by the open source library.
Actually, GBIF has now an API for its validator. So if you wanted to use the GBIF validator, you can now use it with the API. So maybe something to add, but that was not going to be my question. My question was going to be, so did I understand correctly that your the archive you're generating doesn't contain metadata, or?
Yeah, it's just the CSV file for tables.
Okay. Because I was going to say, if it did contain metadata, maybe you could publish directly to GBIF without going through an IPT. But no, no metadata interface yet. Okay, thank you. It looks great. Thank you very much.
Thank you.
Related to that comment about the IPT, I was wondering, because from my point of view, I think there are overlaps there. So my question is whether you consider precisely to extend the IPT with all these features rather than implementing another tool.
Because it's the offline application, so we hope that the user could use this application on their maybe computer or laptop whenever they want. So maybe it's the reason that we separate the application from IPT. Thank you.
Well, that was an extended session, Q&A. Thanks, Jim. Now, moving on, I'd like to invite here to the stage Juan Saez for his presentation.
Yes. Good morning. I am Juan Saez. I get really nervous when I present in public, so please. Thank you. Well, I'm going to talk with a vibrato, so I hope it's not an issue. I am Juan Saez from the Institute of Ecology and Biodiversity of Chile, IEB for short. and I am here to present a Python library for reading, writing, splitting, and merging data core archives files, meaning the zip compressed ones. Biodiversity databases on national scale need to manage their taxonomic catalogs securely and with the participation of local communities of naturalists working in biological collections. Considering this, one of our objectives as an institute is to manage a national biodiversity inventory using different sources to advance in a collaborative managed taxonomic catalog infrastructure. Just those words for saying that different local communities, as shown in the figure, need to curate its list of species in the way they need. The idea is for them to explore a Darwin Core archive files, and those different files need to be merged into one archive that we then use as the taxonomic index of an ALA-like portal of biodiversity. For this main reason, we need a way to manipulate Darwin Core archive files locally, like our personal computer or a server. As a context, the Institute of Ecology and Biodiversity of Chile, a state-funded institution and a cooperative group of researchers in a cluster of many Chilean universities. One of our specific goals is to develop a national species inventory and make it available to the general and specialized public. We intend to generate this inventory to establish the taxonomic index for a living atlas we are deploying for Chile called the Portal of Biodiversity. We have taken the first step with the digital herbarium. The occurrence at this herbarium have been standardized with the Catalog of Vascular Plants of Chile. This catalog is the most up-to-date catalog of Tracheophyta in Chile, being updated in real time for the University of Concepcion. So, digital herbarium consists of two Django projects. The first is a platform for internal data management that we call iBiodata. The second is the digital herbarium itself platform, which is available publicly. I left you with the QR to visit the site, but the first one just is a login page, so it's just there for if you want. The second one is public and it contains all the digital herbarium data. So, the iBiodata platform also has three main components, one for managing the digitalization work, another for the catalog curator in a friendly graphic way, and the IPA, which is the component for sharing the catalog and herbarium information with the internet. The information is also accessed for the display platform on the digital herbarium. The point of showing all of that is to show how the processing pipeline of the digital herbarium works, and is to show also that it is already implemented using Django, which is a framework for software implementation in Python. Python is also a programming language that is broadly used for data analysis. For those reasons, we decided to use Python to export the catalog data to Darwin Core Archive and then merge several of them into one new national inventory. In this process, we develop a library that can read, process, and grab Darwin Core archives. The features that this include you can read an archive in zip format directly and converts information to Python objects so you can work with it programmatically. The library also includes EML classes for writing ecological metadata and works with them using Python scripts or notebooks. Optionally, you can extract any table files from the archive and send it to pandas or polar data frame. Pandas, for those who don't know, is broadly used to manipulate tables in Python similar to R syntax. Polar is like pandas with optimal performance and the capability to do lazy evaluation, which means files too large to store on RAM can be assigned and then evaluate on just when you need to work with them. And finally, save the archive as a zip file, including its data, core, and extension, and metadata files. We use this library in this pipeline to generate a first draft of the National Species Inventory, waiting to merge several Darwin Core archives with their accepted names and synonyms in a new Darwin Core archive. But as the first approach, instead of all the institution I show, we are going to use the catalog of life as a core and add the add the catalog of vascular plants. The first step was extract all the species that GBIF report are present in Chile. After download that Darwin Core archive, we filtered the catalog of life with lists to to extract just the Chilean species, using methods for the library itself as shown up there. The merge archive will be the core of our inventory when integrated with the specialists and specific taxa as the vascular plants. There. Because we have direct access to the herbarium data, as I showed before, we are constantly standardizing its information to Darwin Core. So we can extract its information and explore a Darwin Core archive using the library. And finally, the Trachophytes are extracted from the catalog of life, so there are no duplication, and then we can merge them both using the method merge from the library. This new archive integrates the updated species into the living atlases of Chile. All the code implemented for this pipeline is available on the public GitHub repository as Jupyter notebooks, as I showed there in the QR. I wait. Thanks. Finally, our library future steps are use cases. The pipeline I show is the library primary use case, but we implement it to be as abstract as possible. So other cases may appear. We expect you to use it so we can implement new particular or common features for biodiversity information processing. I want to thank the sponsor of this project and my institution for the funding, and another institution that also fund indirectly the institute. I promise I am not like that speaking personally, so if you want to use the library or have any doubts, don't hesitate to get in touch with me. We aim for this library to be used and be improved by it. Thank you.
Thanks, Juan. So, any questions for Juan here in the room?
Apology if I missed that. I was also anyway. It doesn't matter. How do you publish on like aggregator platforms once you have your? Do you publish afterwards your Darwin Core archives?
The Darwin Core archives are not going to be published for the whole world, and that's because political reason. And the idea is that the data in it is going to be available by the portal. So the library was for working it locally.
Okay, thank you.
Yeah, that's actually an issue for us. I really want that data to be published by the owner of the data, are not us, are other institute, and there are really they have a lot of apprehension about sharing it globally.
Any other questions here or online?
Anyway, the code is available in the notebook I showed.
Hi.
Hi.
I wanted to say you did a great job. You don't need to apologize, okay? Honestly, we're all here for you, right? So take a deep breath. Yeah, it's good. I want to say kudos for making those pieces open that you built. That's great. Our community loves to see that. And the last thing I'd say is, are you interested then? There are those of us who have had to be part of or want to be part of navigating the conversation about with administrators and the directors that you're talking about that feel unsure about sharing data. And there are people in this room who've been part of those kinds of conversations. So if you want to talk about that, and I think there are maybe opportunities in the future where this meeting might be in the Southern Hemisphere, and that would be possibly an opportunity for those administrators to come and see sort of the benefits of what other countries are getting when they publish their data.
I love to. You can contact me directly here also, and another of my colleagues is the one that has that is responsible for the work of conversating and integrating things. So I can also share the contact of him. As Ricardo Segovia, my colleague that come past years.
So, and I'm also not saying that I'm this person. I'm saying there are, I am happy to be part of the conversation. I'm saying that there are people in this room whose that's part of what they actually do and what their organizations do, and they can help you navigate that space if that's something you want to do.
Yes, yes, we'd love to.
Okay, can you come say it so that everybody,
I mean, if you're considering, for example, sharing data on GBIF, we can put you in touch. I can put you in touch with the GBIF node manager for Chile. So.
No, we have contact with
Lacey,
them.
yeah.
The issue is not them. It's the well. I don't want to say it like.
I know. No, it's fine. It's fine. We understand. We've all heard those arguments. I think it's fine. There are concepts.
Yeah.
It's fine. Yeah. I'm just saying that. Yeah. Thank you.
We have been work for the Chilean node, that is the Ministry of Environment. Yeah, they are not the issue. The issue is other institutions that are
That's
not.
all right. Yeah. Yeah. Thank you.
Sarah, do we have anything online? No question. No? All right. Well, in that case, well, I can jump in and now moving slightly on the technical space. I saw that library that you produced, guys. I think we need to have a conversation because one of our teams, our science team in the ALA, is also producing something similar, both in Python and R. So I think it is a good conversation just to join forces.
Yeah, okay. We gladly.
Thanks. Any other questions here in the room? Well, if nothing else, well, let's put your hands together for one more time, please. Thank you. Thank you. All right, well. Yeah, we are running ahead of time, so unless you want to jump in now, Niels, or unless you want to jump straight away, or? Sorry?
So, Niels.
Yeah, okay, well. Let's put your hand together for Niels that is going to dance. Well, our next presenter is Niels Klesenga, so up to you.
I'll just waffle for 7 minutes longer. Good morning. We'll do that afterwards, right? Good morning, my name is Niels Klaassen. I'm from the Royal Botanic Gardens, Victoria, and the Atlas of Living Australia. I'm also the convener of the Taxon Concept Schema Maintenance Group and the TCS2 Task Group. So it's my duty to talk here about the subject that, about the topic that you've heard lots of people complaining about. During this conference. That zero is from the CCC. That was not in my presentation. Yeah, so this talk was supposed to be an introduction of a symposium about expressing TCS in expressing circumscription in TCS, but didn't get any abstracts for that except one, so it needs to stand on its own now. And yeah, maybe since all the questions have been raised at this conference, it's probably talking about circumscription, it's probably jumping the gun a bit, and we need to take a step back. So I'll be just talking about the work we have been doing on TCS as the TCS2 task group that has been working on the new version of TCS. So before I dive in, I first would like to acknowledge that we are meeting on the lands of the Ryukyuan people today and during the whole conference. So TCS. We actually started thinking about TCS again at the previous joint SPNHC and TDWG conference in Dunedin at the workshop that was organized by the then taxonomic name and concept interest group. Some of you will have been there, and at that stage, at that workshop, we decided to look into TCS again and do a review and do also look at other specifications or things dealing with taxa and see what's relevant and what we can use and not. So 3 or 4 years ago, we decided that the best way to go was actually, since TCS already direct or a TDWG standard, the best way to go was to turn the the TNC, or Taxonomic Names and Concept Interest Group, make that the maintenance group for TCS, so we can maintain TCS under the the vocabulary maintenance standard, and so at that stage. The TNC became the TCS maintenance group, and we also wrote a charter for the TCS2 task group that that would make the new version of TCS that actually was maintainable. And the thing is that TCS is as I said, it is a TDWG standard. It's one of the old TDWG standards, and it's just like ABCD and SSD, it's a standard that's an XML schema. So that's what S stands for. And that was at the time, that was the state of the art. But at the moment, currently, there are very few people still, at least in our domain, there are very few people still using XML. So TCS is not usable, and because it couldn't, and because so many people, so few people can use it, TCS was also not maintainable. So if there was an issue with the standard, and people had lots of issues with the schema, then it couldn't be maintained. So, what the job of the TCS2 task group was taking TCS out of the XML and making it into a vocabulary standard, just like Darwin Core. So that all has terms and definitions, but doesn't impose a certain format or data structure. And so we are almost ready. So I've been on long service leave for the last 3 months, because otherwise it would have been in public review, would have gone through public review before this conference, and now I hope very much that we get it ready for public review at the end of this month. This is what we've come up with. You've been looking at it for a while now, so you know all about TCS now. It's very small, so I don't expect you to be able to read it, but it's you can find it on that on the link that's there. Very small standards compared to the other TDWG standards, and not all of that is actually TCS. So TCS is has 2 main classes. So the taxon concept is the top green one, and the taxon name, which is the top red one, and then there's 2 smaller classes. So we got the nomenclatural type, which belongs with the name. So that's for typification of names. We were told to fix that because Darwin Core needs that as well. And the other one is the taxon concept mapping class, and that's is actually quite similar to the Darwin Core resource relationship thing, but Darwin Core resource relationship cannot be used with linked data. So, because it doesn't have an equivalent in the Darwin Core IR namespace, so we have actually made one, but it's specifically for those mappings. So those actually terms have more meaning than the terms in the resource relationship class, or more specific meaning. And so then the top one is references. It's out of TCS, and it's outside TCS, but it's incredibly important for TCS because every class links to the reference, as you can see. And so then the blue one at the bottom is a diamond core preserved specimen, which you need for the type. So it's a type specimen. You can also now use the material citation, which is a new one in diamond core since last year, I think. And the bottom ones are all controlled vocabularies, which we don't have in TCS yet. It's not in the first release. We'll do that later. As at the moment, GBIF have good vocabularies for those, so we recommend people to use those. And that's it. So what you also can see, there's an incredible amount of relationships between the classes. And so the relationship between taxon concepts, relationship between taxon concepts and taxon names, and relationship between and lots of relationship among names. And yeah, so also I'd like to note that pretty much everything you can do is with TCS, you can already do in Diamond Core. Everything is already in Diamond Core. We actually borrow a lot of terms from Diamond Core, and yeah, as long as you're willing, as long as you're happy to work with only strings and CSV. And so the biggest problem at a very high level between Diamond Core and TCS is that Diamond Core has combined the names and or the taxon concept and the taxon name into one object. And you know, because of all those relationships, you can already see why that goes wrong in most cases. So basically, a Diamond Core taxon record is it's a data artifact, and a lot of them have no relationship to anything that you find in nature, and that's the reason why you know, the Diamond Core RDF group, or in the Diamond Core RDF guide, the taxon class could not be included because they had no idea what to do with, and so they stated that that was out of scope of the RDF guide, and that it was a different effort. And so at the moment, you cannot actually use the Diamond Core taxon for linked data, and I think that's one of the problems we have solved. So so we've provided this taxon concept and taxon name, and that can be linked with you know, Diamond Core RDF linked data. And I think that TCS provides for the you know, the Diamond Core taxon what the Diamond Core IRI namespace provides with the for the other Diamond Core classes. Next slide. So what's a taxon concept? So it's so lots of people, so most of the there's been a lot of focus on names, and so a lot of people are completely working in the domain are completely obsessed with names, and I'm actually not one of them. Names are incredibly important, and I spent I only stepped down as the secretary of the nomenclature committee for Briarfights at the last IBC. I've done that job for 18 years, so I wouldn't have done it if I didn't think it was important. But the only reason we're interested in taxon names is because they are the labels of the things we are really interested in. That are those are the taxa. So taxon concept needs to have a label and a source, and that's already, it's not something that I'm saying here, that's what TCS1 already said. So the label, we use the taxon name property, and for the taxon concept we use the according to property. So both those properties are also in Darwin Core, and so the source is incredibly important, and that's why we've made the according to required property for TCS taxon concept. Taxon name is not required. That's not because we don't think the label is not important or less important, but it's because we have some other properties. There's other properties in TCS that can be used for the label, and those include, for instance, the Darwin Core scientific name and vernacular names. So outside the data world, in publication thing, it's always good, or it's recommended if you refer to other people's taxon concept or to taxon concepts in general, to not only use the name but also include the source, and you separate the two by the word sec or sensu. I've got 2 or 3 more slides. I'm waffling too much. No, that's the wrong way. So now circumscription, that's the bit you're missing if you don't include the source. Circumscription, every taxon has a circumscription, and that's basically the definition of the taxon. So you see that the definition and the limitation are synonyms, and also you see to draw a line around. So circumscription, basically putting a boundary around the taxon that says which organisms are in and which organisms are out. So it's incredibly difficult to give to put circumscription in data, but you don't actually always need to do it. What you do need to do is create those taxon mappings, and so you can do so. And these are just taxon mappings are just spatial relationships, so you have these 5 5 different relationships that in these 5 different mapping relations, mostly if you only name, you assume that it's things with the same name, they're concurrent, but they're not always are, and you get conflicts. So, and it would actually be good if an expert can actually do that, rather than you have to do that by algorithm. So you can do it to some extent by algorithm, and that's because it's actually very useful to make spatial analogs, and then it's a taxon. Taxon is a polygon, and a name, because names have types, and names an organism, so that's a point, and then you can see which names fall in which taxon. And with the accepted names and synonyms, you have like a rudimentary circumscription, and that's used in uname resolution when you reconcile 2 different taxonomies. And so you can see from here, there's on the left-hand side is a revision for me, so only 2 species, and or taxonomic my taxonomy, and there's on the right-hand side is the older one, and you see that Dicrano and Brawny, they're congruent, and for Dicrano brevicitum in the older treatment, I actually merged 2 species from the older treatments. That's Dicrano brevicitum and Dicrano leucophyllum. So you can see that Dicrano leucophyllum is a synonym of the. So you get these. What is it? Taxon mappings which you can do. And I think that in the what is it, in the name resolution or in the building of a taxonomy tree, like organizations like GBIF and ALA do routinely. It's never routine, but they do it frequently. That those mappings are actually created under the hood, but they get thrown out at the end, and that's the big shame, because you can only work with what's in the data, and it's impossible to get all the correct mappings, or to know that you get all the correct mappings from the data alone. So it would be really good if those are actually. There's my last slide. If they could actually saved, so we could actually see if they could actually persist it, so people can, so experts can go in and say this is a wrong mapping, or these mappings you are missing, and so you can make better taxonomies. And yeah, that's it. So in conclusion, yeah, so that would be good. And also, since we are also in spinach here, I would say it's also very good for to have taxon concepts in your collection management systems, because what is it? Yeah, it's. Yeah, some collection management systems have them. I think Symbiota has it, and also Arctos, but the CMS that I'm using, Specify, does not. And I think that should change. And the nice thing of having, taxon concepts rather than just the names, is that, a few years ago at the TDWG conference, there was a whole symposium about updating nomenclature in collections. You never have to do that anymore if you have taxon concepts rather than. And so I would like to conclude that we're bringing TCS2 out at the end of the month, hopefully, and it's not going to resolve all the problems that we have, because we're basically dealing with a massive data quality issue, but it's a start, and we can have the discussions about it. I'm done. I talked a bit longer, so I should dance a little bit shorter.
Thanks, Niels. Yes, all right. So, do we have any questions for Niels?
There are questions
online.
Online, yes. Question and comment from Dimitri. Thanks for TS2 version 2 work. It's great you decided to decouple terms from archive structure. Where do you see possible usage of TCS version 2?
Oh, everywhere.
Everywhere.
Everywhere, I reckon. It's yeah, well, the thing is, taxon concepts are used everywhere, but we, try to identify them with name identifier, and that's the big problem. So, I think once we've got a new version ratified, the next thing you have to do is set up a task group to talk about how to do the IDs correctly, and
okay.
But I think they're applicable everywhere. So everywhere where you now use a Darwin Core taxon, they should really be replaced.
Thank you. There is a comment from Matt Yoder as well. If you want to record data at the taxon concept fidelity level, TaxonWorks has full support, albeit different labels for the concepts outlined here. With well-developed referencing, integration, and complete isolation of concepts from names and RCC5 support, we would welcome in-depth exploration.
Yeah, me too. I think TaxonWorks is actually a big part of the solution of the problem, because the checklist that we are getting is yeah, they don't have the complete concepts and the mappings, and yeah, we need tools that that help people with creating those checklists and force people to do it right. So.
Thank you.
Well, that brings us to the end of the conversation for this session. Any further for Thanks, everybody. And now let's go to morning tea. Thanks, everybody online.